This is part of the tedious work, guys. Cleaning up these, here's a brand new crank bearings that go on the end of the crankshaft. And they go down in here in this case, and there's some rust and stuff all over these cases. It doesn't have to be smooth and pretty and, you know, ready for the SEMA show, but you should get all the rust off and all that muck loosened up down in there and cleaned out, because what you don't want is you don't want any of that rust breaking loose, you know, at high temperature, high RPM, and smacking up into the inside of your big end bearing or your wrist pin bearing, or working its way out sideways towards the crank bearings. And it's just not good to have all that debris floating around in the engine. So I'm not trying to make stuff pretty. I'm just trying to get it, all the loose stuff broke loose, so that it won't come off when the engine's running. And once I fire this thing up, 99% of the debris is already cleaned up and out of there. You're never going to get 100%, but you want to get it as clean as you can. See all this muck up here where the glass sand settled when it was laying on its side. Okay guys, I don't know if you remember from the teardown videos, but there was a situation where we had to cut the swing arm bearings out of the frame, to get the swing arm shaft out to get the bike apart, and even just to get the engine out of the frame. And we wound up cutting through this case with a Sawzall, but it had to be done. There's no way around it at the time with the equipment we had. We just had to keep going with what was there to get it apart. So I used some 1-minute oil resistant epoxy to seal it. I got a couple air bubbles down in there, but I think it's on there thick enough. It's not going to be a big deal. So yeah, we got some nice clean engine cases, guys. Look at that. That's some kind of a chemical discoloration and rusting right there. I tried to sand that off and I got all the loose stuff off, but you can see where I cleaned up the part where the bearing goes and all that. So yeah, nice clean cases, guys. I'm going to start putting crank bearings in and seals in. So what you do with this part of the process is you take your crank seals and you look at the two different seals for the two different sides of the bike, and you figure out which side they go on, because they won't go on both. These two bearings are identical. Okay, we'll set them there, but the seals are different diameter. So looks like that one goes in there, and looks like that one goes on the other side. So I showed you guys how to do a lot of this stuff on the RM250 build with hand tools that you had at home, because I knew a lot of you guys would be working at home and you wouldn't have professional grade tools to use while you're doing the job. So I told myself this time I'm going to go ahead and use the same tools I would at work on a customer's bike. So here's a bearing and race seal driver set, guys. This is what we use when we're driving seals and bearings professionally. You take the driver that, in this case, we want to drive this seal facing that direction down flush until it's even with the case. So in order to drive that seal flush, what you do is you get a driver that's slightly bigger. Okay? And you just use that driver to tap that seal down until it is flush. You want the seal facing out like that. Okay? And you take the big flat spot like that. Actually, we'll go this way, because see that there's an uneven surface in there. We want to drive the seal flat to that lower surface. So we'll take the smaller cone. See if we can do it by hand. Not quite. That's good. Just hard enough to get the seal to drive in and not move. So that's it. Seal's flat. Now we'll put these crank bearings in the freezer. We'll get them cool, and then we'll heat this up with a torch and get this steel ring expanded. So with that steel ring expanded and this cooled off in the freezer, then you can overcome that 1/1000th of an inch interference fit, and you can get that bearing to go down where it belongs. So I'm gonna go ahead and put the other seal in, and I'm gonna put these bearings in the refrigerator. Okay guys, we're gonna heat this case up and expand this metal steel ring. I just got the bearing out of the freezer, so with the bearing cooled off and the metal steel ring expanded, we should be able to tap this crank bearing right in. You want to watch your flame. You don't want your flame getting down on your seal like that. See what I'm doing? You don't want to be cooking that seal with that flame. That seal can take a lot of heat when the engine's running, when it's lubricated, but it can't take direct flame without lubrication on that rubber. It'll just destroy it. So you see how I'm heating around the outside, expanding the whole case. Got to be careful coming in right on that steel like that, because that flame can work its way down into that seal. And you can't put the seal on after the bearing from the other side. There's a lip. So the seal must go first. So let's feel that aluminum. See how hot it's getting? Yeah, it's hot enough that I can't hold my hand on it long. Make sure this crank's going to be tight in the bearing. Yeah. Yeah. Yeah, okay. See how easy that was, guys? I mean, that went in with just a couple taps. It was a little crooked to start. I leveled it off, and then once I got a good straight drive, it just popped right down in there. I don't pound the hell out of those to drive them deeper and deeper and risk cracking the case or whatever. It's not necessary. When you put the crank in there and you bolt the engine together, let's say that it is sticking up a couple thousandths of an inch. Let's say it's sticking up a little bit. Well, it'll just bind the crank. It'll just bind it and make it tight to spin. And when you torque all around it and tighten that engine, and that engine heat cycles for the first time, it expands and contracts, gets hot and cools off. I've actually heard cranks. I've actually put two strokes together at the track without the right tools and not had the right wedges and crank pin tools to get them in straight, and just smashed them together to go get points and get championship points and win championships. And I've actually started engines up and heard them warming up, and while they're warming up, you can hear them go pop, 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 crack, crack, and it's the crank, and the crank bearing's finding home. So don't worry if it's not 100% super driven in there. That's not critical. All right, we'll start heating this side up. Now this case is nice and flat and level with no dowel pins, and you can tap it on a level table. This side you got to watch. You got to put this side up on a block of wood, and hit it like that, because of the way the case is made. There's irregularities under there that are not level. So I'm going to heat this up. The other bearing's still in the freezer, still getting cold. Yeah, that bearing right there is nice and cold. I just pulled it out of the freezer. It's been in there a good while. It's been in there about 40 minutes. There's cleaners and alcohols and chemicals that was laying down in the case that cooked off and got lit on fire there. Blow that out. Yeah. So this case is good and hot to the touch now. I can't hold my hand on it. This bearing is really cold. I just pulled it out of the freezer. And you'll see that interference should be nice, easy drop. Look at that. Look at that. See that, guys? Now when when that aluminum cools off and the bearing heats up and they equalize, it'll be too hot to, it'll be too tight to move. There's actually about a 1/1000 interference fit on those parts. Now, if you have an old set of cases that are damaged and they're worn out, and by the time you sandpaper them and clean them up, it makes that steel ring too loose. There's professional super heavy duty grade Loctites that you can get, that you coat that surface with, so that when you get that bearing set down in there, for lack of a better term, it glues it tight so it can't wiggle around. Okay, this one's good though. This one's good. I had to actually press it with my fingers, which tells me that by the time it cools off, there's going to be an interference fit. So this one's good. But if you had a bearing that was loose in the case, you know, it's not good to side load one little part of the ring. But I mean, if it was for an old dirt bike like this, you could even just weld a TIG bead across that steel surface and then grind it down, leave it sticking up a couple thousandths of an inch. Yeah, it's going to load the bearing wonky in one spot. But, I mean, come on, guys. It's not NASA. How much money do you want to spend on your $1,000 dirt bike? If you want to spend $8,000 on your $1,000 dirt bike, go ahead. If you want to spend $1,000 on your $1,000 dirt bike, then this is how you do it, okay? Yeah, see that grease is getting loose and starting to melt because all that heat from the aluminum's soaking into the metal and heating it up. So that's in an interference fit now. That's super tight. That's not coming out. Okay, guys. We got the crank bearings in. We got the seals in. See how they're lipped? See how they had to go in first? Can't put them in. Can't put them in after the fact. So the tighter seal goes on the left side of the crank for the flywheel, and the big wider seal goes on the right side. So always, always, always new crank bearings and crank seals when you rebuild these engines, guys. It's critical on these old two-strokes. All right. Wear your helmets.